Hello, in this video let us talk about applications, which means word problems. So word problems usually involve three steps. The first is setup. The setup is usually related to first vocabulary. So we must know the terms. And then there would be some related math concepts. So the concepts might be from geometry, maybe volume or area, or it could be from algebra, could be factoring, elimination, substitution, could be from trigonometry, from calculus, from any other field. And those particular words, the terms and the concepts, they make up our setup. Now when we do the setup, the unknown is usually called X, or whatever else makes sense in the content. So it could be that L is better unknown for the length, or H is better unknown for the height, or something else. So we choose the letter that will remind us of what it is that we're actually looking for. And then the second step is we solve our setup. Now, when we make our equations, we have to make sure that there is as many equations as unknowns. So if our original setup had just one letter unknown, then it would need one equation. If we had two unknowns, x and y, then we would need two equations. If we had three unknowns, x, y, z, we would need three equations. So whatever the setup we happen to have, those are the principles we use now to solve. So solve simply using related concepts. Related concept. So in other words, using the principles that are associated with our setup, we now use them to solve. And third is we check. And the reason we check is, first, it's possible that we made a mistake somewhere in the process. So to catch it, we check, and we always check by substituting into original. It must be original question, because we don't know at which state, which part of the process we might have made a mistake. If we did know that, we wouldn't have made it. So since we don't know that, we have to go back to the very beginning and see if our answer actually makes sense in the content of what we are looking for. So that's one reason to check. The other reason to check is sometimes, even if we do everything perfectly right, such as squaring both sides, that's a legitimate procedure, we might pick up solutions that don't work. And those solutions are called extraneous solutions. And extraneous solutions mean exactly that. It's a solution that don't work. So we must go back and see, do we have any of those? And if we do, we have to toss them out and make sure we don't include them in the solutions, because they don't actually work. So squaring both sides oftentimes adds extraneous solutions. Working with logarithms oftentimes adds extraneous solutions. There are other situations where that happens as well. So to make sure we don't run into one of those, we go back and check. And then finally, the other important piece is the terminology, or the vocab. So for just a study, it may be a good idea to have a cheat sheet of terms and key formulas that are related And it is scientifically proven that if you write the information on a white piece of paper with a blue ink and actually handwrite the information, your retention will go up considerably as opposed to typing. If simply looking and listening is the minimum contribution to your memory, handwriting it and speaking it and actually working with it will stick in the memory the best. So even just taking a few pieces of paper and writing a formula over and over again, paying attention to what you're writing, will contribute much more to the memory than taking a flashcard and looking at it and back and front and trying to picture it that way. So writing is very important. So here is let's look at some key simple words that we run into. First of all is plus, right? So what words do we have for the plus? What words do we have for the minus, multiplication, division? These are the key operations that we do, and we must know what they are called. So let's find some synonyms, some similar words that go with this. So this symbol is called it's called a plus, it's called a sum, it's called add, it's called more, increase, by, and so on. So we keep room just in case we need to add more terminology. So if somebody says you have $10 more, that means plus 10. Or if your vacation has been increased by 2 days, means you got extra 2 days, and so on. Now for the other one, we have minus, we have difference, we have subtract, we have less, decrease, and so on. This would be multiply, multiplication, times, product. Sometimes the word of actually leads to multiplication. If somebody says 20% of my salary goes to pay the mortgage, that means 20% times whatever I make goes to pay the mortgage. So for instance, if I make $1,000, then 20% of my $1,000 is rent. And that's what of oftentimes represents, is a multiplication by something else. Then the last one is divide, quotient, ratio, fraction, and so on, proportion. A few other words that we see, one of them is, that means equal. So if something is 10, that means equals 10. The unknown oftentimes shows up as what? We call it x. The percent is made up of two words. Per means divide, and cent means 100. So this literally means divide by 100, or divide by 100. And that is basically it. These are the terms that the words that we often see in a setup of many word problems. Let's look at a couple just to see how that plays out. So here's the first example. A sum of a number and 10 is twice as much as the difference of a number and of a number and 3. So the first step is to translate this into something that is math, because if it is math, then we can solve it. It's not easy to solve it in this form because there is nothing to solve. So sum means add. So here we add in, what are we adding? We add in a number, and 10, which is, that's equal, twice, that's double, as much as the difference is minus. Difference of what? Of a number, that's x, and what else? And 3. So this is the translation of the words into the math. And from here, we use whatever principles that are related to this setup to solve it. In this case, that would be the order of operations or PEMDAS. So following the order of operations, we simplify and then we solve. So the only thing to simplify here is the multiplication. 2 times x is 2x, 2 times negative 3 is negative 6. The rest of the question is unchanged. We copy it over. Now we have x on 2 sides. We need it on just one side. All unknowns on one side, all the numbers on the other side. Let's say we move the x's to the right, so we cancel the x by subtracting from both sides. That makes 10 equals 2x minus x is 1x minus 6. Now since all my x's are on the right, I want the numbers on the left, which means cancel the negative 6 by adding it to both sides. And we're done. X is 16. Now to check, we go back to our original setup, which is here, and we replace each x with 16. So 16 plus 10, does that equal to 2 times 16 minus 3? Well, 16 plus 10 is 26. Is that the same as 2 times 16 minus 3 is 13? 2 times 13 is 26, so true. Our answer works, and we have solved our word problem. Now let's look at one example, 2 more examples. This is a bit of a long note, but just to illustrate how all of these plays out, let's look at a few more. So here is example. 15 is what percent of 75? So going straight into the setup, 15 is means equal, what, that's the unknown, percent means divide by 100, of means times 75. So at this point we see that we have 75 divided by 100. We could simplify that, or we can simply undo everything and get x by itself. So to undo divided by 100, we multiply both sides by 100. So times 100 times 100, these cancel off. That makes 15 times 100. To undo the multiplication by 75, we divide by 75 both sides. 75, 75, 75. These cancel. This is the answer. All I need to do is type it in my calculator to see what comes out. Or I can just reduce. 100 and 75 both have 25. 25 goes into 75 3 times, and into 100 4 times, which means 4 times 15 is 60, divided by 3, which is 20. Of course, we could just type it in the calculator and get the same result. And the last example is what number is 30% of 80? So what is the unknown? Is means equal, 30% means divide by 100, of means times 80. And this simply goes in the calculator, or we can reduce by 10, reduce by 10 again, and that leaves me with 3 times 8, which is 24, and that's the answer. So these are some word problems and some terms that we often run into, and the basic principle of how to deal with it. Thanks a lot for your time. Take care.